Okay, let's take a look at this ALEKS problem. This is a heat and work type problem. First law of thermodynamics. A mixture of gaseous reactants is put into a cylinder where a chemical reaction turns them into products. So inside that little box there, that little cylinder, that's where the reaction is occurring, where it says gases. The cylinder has a piston that moves in and out. In or out means up or down, okay, as necessary to keep a constant pressure on the mixture of 1 atmosphere. So keep in mind, constant pressure, that's significant in terms of our discussion of enthalpy. If we're at constant pressure, then the enthalpy change is equal to the heat exchange. The cylinder is also submerged in a large insulated water bath, okay? So that means that all of the heat is going to be transferred into the water, and the water will change temperature, and that's why the thermometer is in the water. Outside of the water is an insulator, so that means that the heat is not going to go out of the water and into the insulator because the insulator keeps the heat trapped in the water, okay? The temperature of the water bath is monitored, and it is determined from this data that 326 kilojoules of heat flows into the system. So that's into the gases, right? The reaction mixture is the gases during the reaction, okay? The position of the piston is also monitored, and it is determined from this data that the system does 247 kilojoules of work on the piston during the reaction. So again, on the piston, okay? So let's go through here. Is this reaction exothermic or endothermic? Well, remember, endo and exothermic has to do with Q. If the reaction releases heat, then Q is negative. It's less than 0, right? And that means it's exothermic. If Q absorbs heat, not if Q, we're talking about Q. But if the reaction absorbs heat, then Q is greater than 0, and that's endothermic. Okay, so let's see. It says it flows into the system. That's endothermic, right? Heat's going into the system, so that's endo. Okay, what happens to the temperature of the water bath? Does it go up or down? Well, if heat is going into the reaction, that means it's coming from the water. So that means water is losing energy. If water loses energy, it cools down. So the water is going to go down in temperature. If you add heat to something, it'll get hotter. If you take heat away, it'll get colder. Does the piston move in or out? Okay. Now, what we have to do is we have to take a look at work. So what's going on in terms of work? It says that work is done on the piston. Work done on piston. So what's happening is the gases, the reaction, remember the reaction is the gases, are doing work on the piston. That means it's pushing the piston out. It's moving that piston up. Okay, it went up. So if we're doing work on the piston, that's the same as work on the surroundings. S-U-R-R. Okay? So that means that the piston is going to move out. It's going to move away. The way I knew that is because it said here 247 kilojoules of work is done on the piston during the reaction. The energy is going from the gases to push that piston up. Does this reaction absorb or release energy? Okay, well that's where we get into delta U. Delta U is Q plus W from the perspective of the system, which is the gases, right? Okay, so let's see. Oops. Sorry there. Darn. There we go. Now we can see it. Let me just bring this down a little bit. Does the reaction absorb? Okay, so we have a couple numbers here. We know that it's Q is negative. 326 kilojoules. I'm sorry, plus, because it's flowing into the system. And then it's doing work on the surroundings, so that's minus 247 kilojoules. So what is that? 79, right? I think that's 79. Okay, so that's from the perspective of the system. So what happened to delta U? It went up by 79. So it will absorb energy. Okay, how much does it? 79. 2 sig figs, right? Went up by 79. So really, you're just figuring out, is this positive or negative? It tells you the value. It's 326. You just need to know whether it's positive or negative. And then they're telling you this one as well. You need to know whether it's positive or negative. Well, it's negative because the system is doing work on the surroundings. So W is negative. And then Q is positive because it says that it absorbs energy. It absorbs heat specifically. Okay? So there you go. That is the first law of thermodynamics, or understanding the definitions of work and heat from the perspective of a gas piston, a gas cylinder. That is the most common example of heat and work problem that we do.